Hi guys. Okay, so let's continue on with the chapter 7, chemical reactions and quantities. So we already covered the chemical reactions, but now we are going to look at the quantities, which means the stoichiometry. So that's a very common term that we often use for quantities. That is stoichiometry. Now, when we look at the chemical reactions, we are looking at the reactants, we are looking at the products, and we understand that, you know, the atoms, they exchange places and then they form a new product. But the problem here is that when we want to take measurements, in other words, when we want to do some calculations, when we want to take the weights, it's hard to take the weight of the atoms because we can't see them. We cannot see the weights, we cannot see the molecules. So how do we take the weight of the molecule? So that becomes a challenge. So there should be some ways to quantify the amount and know how many atoms or how many molecules are we looking at. So here's the thing. Just like you have a dozen and 1 dozen means 12, right? So same is the case, 12 of anything. Same is the case, there is a unit for moles, and that moles is also a certain number of particles. Okay, so let's look at this. For example, if you have 1 dozen pens, okay, so this clearly means that there are 12 pens, and these 12 pens have a certain weight, okay, and that weight is only of 12 pens. Next is, let's look at 1 dozen candies, okay, so 1 dozen candies, once again, 1 dozen candies is going to be 12 candies, and these 12 candies again will have a weight of the candies. So the weight of the pens and the weight of the candies is different. Okay, so the weight of the candies could be more, could be less, depending what's the size. So again, there is a difference in the weight, but something is same, and that same is the number, the amount. Okay, and this unit is the same, which is 1 dozen. So again, 1 dozen apples. 1 dozen apple, we always, you know, look at it. So these are 1 dozen apples is 12 apples. So the weight of the 12 apples is totally different from the weight of the candies and that of the pens. So that is, again, this is the weight of apples, which is totally different. So you see that the amount is the same. That relates to dozen. But the other pieces are different. So the same thing we see with the moles. So 1 mole of anything, okay, 1 mole particles, and this particles could be anything, particle of anything. This means that there are 6.022 into 10 to the power 23 particles. Okay, now that's a big number because basically we are dealing with atoms. So that is why we needed that big of a number. So 1 mole particle is 6.02 to 10 to the power 23 particles, and whatever the weight, whatever those particles are, is that's the weight of those particles. Okay, then comes 1 mole of same thing, 1 mole of pens. Same thing, this is going to be 6.022 into 10 to the power 23 pens. Now that's a lot of pens. And again, the weight of all these pens is, you know, whatever the pens are going to weigh. It depends what those pens are. 1 mole shoes, okay, is 6.02 to 10 to the power 23 shoes, and whatever the weight of the shoes come out to be. Now that's like, again, heavier than the pens. Then let's look at this, 1 mole of cars. Okay, now that's a lot of cars, 6.02 to 10 to the power 23 cars. And look at the weight of those cars, huge amount of cars. So you get that picture that The weights vary, but the total amount of the substance remains the same. And we see that they are all 1 mole. Now look at this, 1 mole atoms, 1 mole, where did I put this? 1 mole atoms. An atom of anything is equal to 6.022 into 10 to the power 23 atoms. Okay, and whatever that those atoms are, then that's the weight of those atoms. Weight of those atoms. Now, where are you going to get this information? This piece, you're going to get the weight of those atoms, you're going to get the periodic table. And in the periodic table, there is mass number. Okay, there is mass number. And that mass number you are going to use. And it's okay to round up here. Okay, next look at 1 mole molecules. 1 mole of molecule. And again, 1 mole molecule contains how many molecules? 6.022 into 10 to the power 23 molecules. And what is the weight of the molecules? That is the weight, that is the molecular weight. Okay, or it is also called a molar mass. So write down here, first of all, the molecular weight. And this molecular weight is also called a formula mass. So whatever the weight of whatever the formula is, so the formula mass of the formula. Okay, and later on, we also call it molar mass. Molar mass. Okay, so the formula mass, the units are atomic mass units. Molar mass, the units are grams per mole. So we are going to look into this. Okay, so this is this 6.022 into 10 to the power 23. This is of anything, and this could be anything. This applies to anything. I mean, obviously, this was done with the intention of, measuring the weights of the atoms. But this is if you have these many amount of anything, that is called the Avogadro's number. So Avogadro's number. Okay, so now let's look at this example, Avogadro's number, and we can actually look at now the different conversion factors using this. So conversion factors. Okay, now we are going to look at, for example, iron, for example, and you can use it for anything, for example, for iron. Okay, now here we see that the conversion factors are for this equality. These are the equalities. So this means that 1 mole of iron contains 6.022 into 10 to the power 23 atoms of iron. Okay, and what is the weight of that? That is the mass number of iron. And what is the mass number of iron? If you look at it in the periodic table, iron is in group 3D, like in the third, like it's actually in the 4th row, but you will see that iron is present in the, it's 55.86. So 55.86 can be written as 56. So it's okay to round up. Okay, so 56 grams of iron. All right, so here we use iron. Now let's look at it another example. For example, you have water. Now there is a difference between this molecule. Yes, this is also 1 mole of 1 mole of H2O, which is the water, and that is equal to 6.022 into 10 to the power 23 molecules. So if it is a molecule, you're going to write down molecule of water, and the weight, the molecular weight is 18 grams. And we will look into this, 18 grams. So that is the, so here, this is the atomic weight. This is the atomic weight, or the weight of the atoms, or this is also called a mass number. And the next one is the molecular weight. Molecular weight. All right. Now let's look at the conversion factors with regards to the top one, iron. So 1 mole of iron contains 6.022 into 10 to the power 23 atoms. That's the particles of iron. All right. Another thing is 6.022 into 10 to the power 23 atoms of iron, over 1 mole, and obviously it's 1 mole atoms of iron. Okay, this is one conversion factor. Another conversion factor is 1 mole of iron contains 56 grams, the weight of iron, or 56 grams of iron, 1 mole of iron. Okay, next is the number of particles. So 6.022 into 10 to the power 23 atoms of iron are present in 1 mole, and we already have that, are present in 56 grams of iron, or 56 grams of iron contains 6.022 into 10 to the power 23 atoms of iron. All right. So these are the different conversion factors depending upon what we are looking for. Now, let's look at one example in which, let's look at this one example. You are given, let us say, I'm going to just make up one example. Okay, here you are given 5.25 grams of iron. So the question is, this is one example. This is just an example question or sample question. Is 5.25 grams of iron. Now the question is find how many moles is that? How many moles? Okay, and the questions, this is the first question. Second question is find how many atoms are in 5.25 grams of iron. How many atoms of iron? How many moles of iron? And here, how many atoms of iron are present in 5.25 grams of iron? So what are you going to write here? First of all, you're going to write down the equality. So equality is that we know that 1 mole of iron is equal to 6.022 into 10 to the power 23 atoms. So that is one relationship. Okay, the next relationship is that 1 mole of iron contains 6.022 into 10 to the power 23 atoms. Oh, I already did that one. Sorry. How many how many moles? Oh, 56 grams here, 56 grams. How many moles? Yeah, for 56 grams of iron, atoms of iron. Okay, so let's do this. So these, you can create the conversion factors as I had already shown above. So let's write down. Here's the thing, always, you write down your given from the question. Given from the question. Okay, given from the question. And in that given, there is a grams. There is some kind of a unit. Whatever that unit is, you times that unit with a conversion factor. With a conversion factor, in the conversion factor, the unit that you want to get rid of is at the bottom in the denominator, and the unit that you want is on the top. The unit that you want is on the top. So the wanted, so these are the wants. These guys find. Find means this is something that you want to find. I mean, you know, that is why you will be setting up the problems like that. So these are your wants. This is your given. Okay. And the conversion factors is based on the equality. So conversion factors come from the equalities. Okay. So that's the numerator that you want to keep, retain, and the denominator, that is the denominator, denominator, denominator. Okay, so you will write this. The unit that you want is wanted, or the wanted unit, or the one that that the question asks you to find is on the top, and the one that you want to remove, or the one to get rid of, basically get rid of. Okay, so that is going to be at the bottom. So now let's set it up. 5.25 grams of iron. So this is your given, 5.25 grams of iron. So write this down here. Multiply by, we want to get rid of the grams. So grams of iron, just put it here. So this shows you that the grams of iron will be canceled out. Okay, so keep that in mind, that these units, the one that is at the bottom, this cancels out, and the one that is on the top remains. That cannot be canceled out. All right, so you see grams and grams. Now first one is to convert, find how many moles. So basically you are given the grams and you are trying to find for the moles. So this is grams to moles conversion. Okay, and I'm going to do this a little bit lower. Sorry. Grams to mole conversion. So 5.25 grams of iron, and we have the other one is the we want to get rid of grams to mole, and the mole we want on the top. Okay, mole of iron. So here we see that 1 mole of iron is equal to 56 grams. So always set it up like this. And where do you get this with 56 grams? That is the mass number of iron. Okay, so you have to look at the periodic table. Basically, all of them are 1 mole. So that's the mass number. Okay, so now we see here that these two guys can be put as 2 conversion factors of this equality, and that is 1 mole is on the top and 1 mole is at the bottom. So the mole that is on the bottom will cancel out. The mole that is on the top remains. Next is, we see that 56 grams, 1 mole, 56 grams of iron. and here 56 grams of iron. So 1 mole of iron. So these are the two conversion factors. So which one we will use? The one that is giving you moles on the top. So this moles on the, this moles that is on the top or in the numerator is this one. And the moles, and now you see with that said that the grams of iron is at the bottom. So that's going to cancel out. So we are going to use this conversion factor. Okay, so now just write down here that 56 gram is at the bottom and 1 mole is at the top. And so with that said, you see that the grams of iron and the grams of iron cancel out. This iron and this iron cancel out, and you are just left with the unit of moles. And that's what you want. You want the moles on the top. You want to remove the grams or cancel out the grams. Okay, so that's what the whole, we're making the conversion factors. So the rest of it is just simple, 5.25. So when you do that, just do the simple math, which is 5.25 times 1 divided by 56. So what do you get here? Okay, so with the, after doing this computation, we see that 0.0937 moles of iron are obtained. So this is a very common, you are going to see this grams to mole conversions, moles to gram conversion. So I'm just letting you this up front. I mean, this whole chapter is important, especially, these conversions, but these type of conversions will definitely be on the test. Okay. All right. So the next one is, let's do how many atoms of iron. Now, anytime there is a thing, how many atoms, that means that we are talking about the Avogadro's number. Avogadro's number. So let's do this. How many atoms are present in 5.25 grams of iron? So this was the first one. This was the first one. Now, how many atoms? How many atoms? That means we are talking about counting those atoms, and those comes out to be 6.022 into 10 to the power 23 atoms are present in 1 mole. And how much is 1 mole, and how many these are, so how many atoms are present in? So you have to find out this in 0.0937 moles. So same thing you will write down here, 0.0937 moles of iron. Now you can even do, like, without going the mole route, you can see a direct conversion between the number of atoms and the weight. So this can also work. These are the two. These can also work. Or you could do the moles. Since we already converted into the moles, that is why I'm using this number. So here is this mole, which is coming from the previous question, and this moles times. Now here we see that 1 mole will be in the denominator, because we are not interested in 1 mole. What are we interested in? How many particles are there? So 1 mole contains 6.022 into the 10 to the power 23 atoms of iron. Okay, atoms of iron. Okay, then 1 mole of iron will be how much? 0.0937 moles. So basically moles of iron and moles of iron cancel out, and you are only left with the atoms of iron. So next thing you're going to do is multiply 0.0937 times 6.022 into 10 to the power 23 over 1. Okay, so let's do this math. Okay, so when you do the math, you get this number. So here, this is the standard notation. This is standard. Oh, sorry, not the standard. can be standard, but this is not the scientific notation. So you will have to move, sorry. So 0, how was that? 564, 5. So here's a decimal. So you move the decimal one place and bring it in scientific notation. And so when you do that, this becomes 5.64 into 10 to the power 22. And that is the atoms of iron. Okay, so these are the grams to mole conversions. And the second one is the moles to the number of atom conversions, or it can also be seen as grams to the number of atoms conversion. So let's put this here, that the number of atoms to number of atoms, moles to the number of atoms conversion. Like that. Okay, now let's look at this problem. Now before we even move that, let's look at the concept of molecular weight. MOLECULAR, molecular weight. And this molecular weight is also equal to the molar mass. Molar mass. Okay, now, okay, so when we talk about molecular weight, so let's look at this one, H2O. So in this molecule, these two applies to hydrogen. And when there is no number written here, this means the number 1. 1 of oxygen, 1 oxygen atom is present, is combined with 2 atoms of, or two hydrogen atoms. Okay, 2 hydrogen atoms. All right, so let's look at the weight now. So here you have 2 hydrogen atoms and the weight of the hydrogen atom is 1. This piece you're getting from the periodic table. Okay, here also the periodic table for the mass number. And you're going to get the mass number from the periodic table for all the atoms. So individual atoms. So here you have 2 atoms of hydrogen, 1 gram each, and that is 2 grams of hydrogen. Okay, so the 2 grams of weight is coming from hydrogens. Oxygen, there is only 1 oxygen, and the weight of the oxygen is 16 grams. It's 15.99, but you can make it 16. So 16 grams is in the total weight is coming from oxygen, and you add, and this comes out to be 18 grams. Okay, now here's the thing. In the past, they were using atomic mass units. Atomic mass units. But later on, they changed it. They said, okay, this is grams per mole. So these are the units, grams per mole. Once the concept of moles became to be used, then they said, okay, this is grams per mole. Means 1 mole of water that contains 6.022 into 10 to the power 23 molecules. Okay, the weight is 18 grams. 18 grams, that's the weight. So if you weigh 18 grams on the machine, that means you are weighing 6.022 10 to the power 23 molecules of water. Okay. All right. So now this is one piece. So let's look at a few more examples. Let's look at the example of aluminum, Al2SO4 whole thrice. Okay, so what does this mean? This means that 2 applies to aluminum, 2 applies to aluminum, 4 applies to oxygen, right? But this outside 3 applies to sulfur, and this outside 3 also applies to oxygen. Okay, so this means that there are 2 aluminum atoms, and this means that there are 3 sulfur atoms, and there is 4 times 3 is equal to 12 oxygen atoms. This is what it means. Okay, that's one piece. Next is, let's look at their weights. So aluminum and sulfur and oxygen. So aluminum is 26.98. So you can easily make it 27 grams. Okay, then comes sulfur. Sulfur is 32.02, 32 grams. And oxygen is 16 grams. All right, so you have here now, when you multiply them, let's see what we get. Okay, so as you can see, I've already taken the weight. So 27 times 2 is 54. That's for aluminum. That many 54 grams of the weight is coming from aluminum. Sulfur, 96 grams of the total weight in this molecule is coming from sulfur. And 12 times 16 is 192 grams of the weight is coming from oxygen. So when you add this up, it comes out to be 34 aluminum sulfate, 34 grams per mole. That's the molar mass. So molar mass of aluminum sulfate is grams per mole. Okay, so this is how you do the calculations. Now for the molar mass. Now let's go back to the study check 7.5, and this is page 253. Page 253, study check. Study check is 7.5. All right. Now here, what do you have here? How many moles of water? How many moles of water? How many moles of water contain 2.60 10 to the power 23 molecules of water? So how many moles of water will contain 2.60 into 10 to the power 23 molecules of water? Okay, so one thing is that you can just go, convert it into the grams and then look at it there, or we know that 1 mole of water contains 6.022 into 10 to the power 23 molecules of water. And this can also be written in the conversion factor. 1 mole of water over 6.022 into 10 to the power 23 molecules of water. Okay, so as you can see, we have eliminating all these off and this and that, all these type of things. Anyway, so that's one thing. Or you can flip it, and flipping is, it could also be 6.022 into 10 to the power 23 molecules of water over 1 mole of water. 1 mole of water. So which one we will take? Because the question is asking how many moles How many moles? So we are going to use this because this moles is what we need. The molecules, we are given the molecules. We are given the molecules. And so we want to cancel out the molecules. So in this conversion factor allows us to cancel out the molecules because they are in the denominator. So when you set up the equation, now how many moles of water are present in 2.60? So write down what is given to you. This piece is considered to be given. This is given, okay? And this piece is known. So even if you know it's not directly stated somewhere, but we expect you to know these equalities, okay? So known equality. So we have been talking about it, quite a while now. So here we have 2.60 into 10 to the power 23 molecules of water. And we want the moles, right? Multiply by 1 mole of water contains 6.022 into 10 to the power 23 molecules of water. Okay, so here we see that the molecules of water cancel out. All right, so you're just left with the moles of water, and that's what we need. So the rest of the stuff is, how do you do that? Now, if it's a scientific calculator, you can do it. If not, then this is how you do it. 2.60 divided by 6.022. And here, just leave this on one side, 10 to the power 23, and here 10 to the power 23. This one is multiplying, right? 10 to the power 23, leave that on, I mean, they cancel out, but leave that on one side. So do this, 2.60 divided by 6.022. Okay, so we get the answer here, 0.431 moles of water. So how? We will just, 10 to the power 23, 10 to the power 23 cancel out. So 2.60 divided by 6.022 gives you 0.431 moles of water. Okay, so this one was again very simple conversion. Now let's look at the moles of elements in a chemical formula. So this is something that we already discussed. We talked about the molar masses, but let's look at it again. How would you, now this is the study check 7.6. So study check 7.6, and this is on page 254. Page 254. Okay, so what do we have here? How many moles of propyl acetate? So the question is, how many moles of propyl acetate? How many moles of propyl acetate? That is C5H10O2. C5H10 and O2. Okay, contains 0.480 moles of oxygen. Okay, so here you are going to look at now that we discussed earlier when we calculated the molecular weight. So here we see C5H10O2 contains, now this is another way of saying it, is it contains 5 mole of carbon atoms are present in one molecule, because molecule is big, one molecule of C5H10O2. Okay, So this is one thing. Second thing is we also see there are 10 moles of hydrogen atom are present in one molecule of C5H10O2. Okay, and similarly 2 moles of oxygen atoms are present in one molecule of C5H10O2. Okay, so these are the relationships. Now we are, how many moles of propyl acetate? Moles propyl acetate contain 0.480 moles of oxygen. Okay, so you are given the moles of oxygen, and these are known equalities, or these are conversion factors. So now we are looking at the relationship between the oxygen atoms and the actual molecule. So leave the rest. So let's write this here. We are given the 0.480 moles of oxygen. So write down your given, and that is 0.480 moles of oxygen. Moles of oxygen atoms. Okay, and the question is asking how many moles of propyl acetate contain these many moles of oxygen. So here you need to cancel out the moles of oxygen. So we see that so this is going to be flipped. This can be flipped. So in other words, all of them can be flipped depending what you're needing. So all of them. Okay, so remember that the one that is going in the bottom is the one that cancels out. So we need from this question how many moles of propyl acetate. So this means that actually it's one molecule. Instead of using the one molecule, we now prefer to use mole. So 1 mole, let me just fix this. So in 1 mole of C5H10, same is the case, because molecules is like, it's an outdated thing now. So it's all mole. So 1 mole of C5H10, 1 mole of C5H10. Okay, so moles of oxygen, and there are 2 moles of oxygen present. 2 moles of oxygen are present in 1 mole of C5H10O2. Okay, so we see that here these moles of oxygen and the moles of oxygen cancel out, and you are left with just the numbers, which is 0.480 times 1 divided by 2. Okay, so that relates to the moles of C5H10O2. All right, let's see. Okay, so when you do the math, you get the answer 0.240 moles of C5H10O2. Okay, so this is how you do that. Next, this is also an example of elements present in a molecule, moles of elements in a chemical formula. So this thing that we did, moles of elements in a formula. So back to square, this piece right here. So this thing can also be said that 1 mole of Al2SO4 whole thrice contains what? Contains 54 grams of aluminum, 96 grams of oxygen, 192 grams of oxygen. Okay, so 1 mole contains these. Okay, and we can also say that 1 mole contains 2 moles of aluminum, 3 moles of sulfur, and 12 moles of oxygen. So that's another way of saying that. Okay. All right. Now let's look at another example. Moles of elements in a chemical formula, molar mass calculations. So I did a little bit complex one, the one with the, the one with Al2SO4 whole thrice, and we can do, let's see. Okay, let's do another calculation that relates to molar mass. Okay, because the one that's given in your book is easy, so I just want to do a little bit more harder. So here is, for example, PB2 CO3 whole 1 second. Yeah, PB, PO4, and this is 3, and this is 2. Okay, so this means that this 3 applies to lead, this 2 applies to phosphorus, and this 2 applies to oxygen. So this means there are 3 moles of lead present in 1 mole of PB3 PO4 whole twice. Okay, so this also means that there are 2 moles of phosphorus present in 1 mole of lead phosphate. Then 4 times 2 is equal to 8 moles of oxygen in 1 mole of lead phosphate. Okay, so that's the you do that. Next is you can just bring in the numbers from the mass numbers from periodic table. And so what is that mass number? So you see that the lead, there are 3 moles of lead times whatever the weight is, 2 moles of phosphorus times the weight, and then 8 moles of oxygen times the weight. So lead is, the lead is 207.2. So 207.2. Phosphorus is 30.97. So this becomes 31.0. So these are grams now. And then oxygen is 16 times 8. So 16 times 8 is 128.0 grams. So that's coming from lead, that's coming from phosphorus, and this one's coming from oxygen. And when you add all these numbers, then you get 128 plus 31 plus 207. And that gives you 366. 366 grams per mole. Okay, and this always write down in what context. So this one is Pb3SO4 whole twice. Always write down. Okay, so this is how you calculate the atomic, the molar masses. So that is the calculation of molar mass of lead sulfate. All right, so this is some easier examples are given in your book. So I'm not doing those, but it simply means the same. Okay, so once again, there is another example of grams to moles, and that is on page 258, page 258. Okay, and the problem is study check 7.8. So study check 7.8. All right, so here we see that the problem is a dentist orders gold to prepare dental crowns and fillings. Calculate the number of grams of gold present in 0.124 moles of gold. So you are given 0.124 moles, okay, moles of gold. This is given. So the conversion factors for the compound is also written from the, here. Calculate the number of grams of gold present. So we are saying grams. So the mass of gold in grams is how much? Okay. So we are looking at the moles to, very important. So this is moles to grams conversion. Okay, moles to gram. So what do we know? We already know. We know of the equality, and that is 1 mole of any substance is equal to, for the gold, the weight is the mass number. So the gold is 197. So the mass number of gold is 197. 197 grams per mole. Okay, so this is equal to 197 grams. So 1 mole of gold is equal to 197 grams of gold. So this means that now if you need the mass of gold, that means out of these two guys, the conversion factor that puts mass of gold on the top will be the one you will be taking. So the two conversion factors are 1 mole of gold over 197 grams of gold, or 197 grams of gold over 1 mole of gold. Okay, so we are going to take this one because it will allow us to cancel out the moles. We are already given these moles. We need the mass. So we are going to write down here the 0.124 moles of gold times. We know that 1 mole of gold is equal to 197 grams of gold. Okay, so let's finish the math. Okay, so this comes out to be 24.42 grams of gold. So we see here that the moles of gold and the moles of gold cancel out. Moles of gold cancel out. Okay, so this is how you get the answer. All right, next is converting the mass of a compound to moles. Now, let us say a tablet of antacid. Now, let's look at this one. Page, this is converting, this is the mass to moles. Mass to mole conversion. So up till now, this one was moles to mass conversion. Okay, so this one is mass to moles. And so what is the, let's write this down. So this is on page 258, page 258, and the study check 7.9, study check 7.9. Okay, study check 7.9, and here we see that study check, a tablet of an antacid contains 680 milligrams. This is an antacid that has, like, you know, the active salt. So anyways, this antacid tablet, and this containing calcium carbonate. How many moles of calcium carbonate are present? Calculate the number of moles of calcium carbonate that are present. Okay, so here the strategy is, because there is no direct conversion of the milligrams to moles, so you're going to convert the milligrams to grams and then grams to moles. So grams to mole conversion, milligrams to grams. So we know that 1,000 milligrams make 1 gram. Okay, or 1 gram over 1,000 milligrams. So that's one thing that's going to take care of the conversion from milligrams to grams. Now, next is the taking the grams and converting to moles. That means you need to go through the process of molar mass. And that converts to moles. So let's do this first of all. One conversion is 680 milligrams times 1,000. 1 gram, sorry. This is 1 gram. Oh, sorry, I made a mistake here. Okay, this would be 1 gram over 1,000 milligrams. Sorry about that. Okay, so here we have the 1 gram of calcium carbonate contains the gram formula mass. So wait a minute. Getting tired. 1,000 milligrams. Okay, so this is going to convert the milligrams to grams. Okay, and this is for calcium carbonate. And this is the, grams, though grams and milligrams conversion. Okay, next is, let's find the molar. So this is going to give you what? This gives you, when you calculate it, 0.680 grams of calcium carbonate. So this is one piece. Second, let's look at this calcium carbonate. So you have 1 calcium, you have 1 carbon, 3 oxygens. Calcium, the weight of calcium is 40 grams. 40 grams. Carbon is 12 grams. Oxygen is 16 grams. So we have 40 plus 12 and 16 threes are 48. So this comes out to be 8, 9, 10. 10 grams per mole. All right. So now bring in the third step, which is 0.680 grams of calcium carbonate times times, we want the, how many moles is that? So moles, 1 mole of calcium weighs 100 grams of calcium carbonate. Okay, so we see that when you set this up, grams and grams, calcium carbonate and calcium carbonate cancel out. So let's do the math now. Okay, so when you do this math, you get the answer 0.00682 moles of calcium carbonate. Okay, so that is the answer, and it finishes one section. Okay, and we are going to do the mole relationships in my next video, but I want you to really start practicing it because it's going to get a little bit harder as we start moving into the reactions, but it's not that difficult. So practice the formula masses and the relationships, and then the conversion factors. These are very important. Okay, so we will stop the video now. And if you guys have any questions, please feel free to ask me. Okay, don't hesitate, but practice. All right. Thank you. Thank you for watching. Bye-bye.